Hello, this is Dr. Perez, and the purpose of this video is to discuss some of the aspects of Lab 7 for our course, Modeling and Analysis of Manufacturing Systems. So let me open the PowerPoint presentation for today's lab. Um, okay, so this is the slides, and I want to go straight to the example. Today, what we're trying to do, or we were trying to model in using Arena, is arrival schedules. So the arrivals now are not following the same probability distribution throughout the timeline. Now we're gonna try to model a process in which you have a different number of arrivals per time period. So that's the idea of the schedules. Let me see if I can get to, so here we are. We have schedules for the arrivals, and we also have schedules for the to change the capacity of resources during the day. But in this lab, we're going to be focusing on the arrival rates and the number of arrivals or entities that arrive during the day. And if we establish that our time periods are hours, then we might have different arrivals or different number of arrivals happening at every hour. So today we're going to be focusing on schedules for the arrival process. So in this particular lab, the schedules are going to allow you to define an arrival rate based on daily time or a calendar. And then the entities are going to arrive according to a schedule that we are going to name. In this case, we're calling it Schedule X. In terms of the parameters for the schedules, in terms of the arrival rate, we need to know how many entities are going to be arriving per time period, and that's what we're going to be using. So in this slides, and showing this, and that's part of the reason I'm doing this video, is because this visual interface to set up the number of arrivals per time period is no longer available in Arena. So now what they provide you is more like a spreadsheet type in which you're gonna enter the number of arrivals and the number of time periods in which you're gonna observe that number of arrivals, which I'm going to illustrate with the example. So once you define the schedules and you provide a name for that new schedule, then you have to go to the create block and define that the arrivals are going to be based on type schedule, and then you're going to search for that schedule that you have created using a particular schedule name. Okay, so we all know how to compute the statistics. So at this point of the semester, I'm pretty sure that you're very familiar on how to create the output report. So let's look at the example. So here's the example. We have a 24-hour store in which we have customers arriving based on a schedule. So you can see that on the red box on to your left. So we know that based on the data that from 12 a.m. to 10 a.m. we're gonna receive, or on average, four customers per hour. And then that arrival process changes when we move from 10 a.m. to 6 p.m. It's about 10 arrivals per hour. And then finally from 6 p.m. to 12 a.m. is 8 arrivals per hour. So we want to model that in this 24-hour store, customers spend some time in the store before they go to the cashier. So we're modeling that time that they spend in the store using a gamma distribution. And then after that, we have 50% of the customers will spend 2 minutes to pay, and then 50%, or the other 50% will take about 5 minutes to pay. We want to do 10 replications, 10 days per replication, and we want to provide a priority to the shortest time first. So that's when you get to the queue, we want to make sure that those customers that take less time are served first. So we want to compute zero statistics, the mean number of customers in the system, the mean number of customers at 6 p.m., and the average cycle time. Okay, so let's go to Arena. So I'm looking for Arena. I'm going to share that screen with you now. I don't know what's going on. I'm going to go to full screen. It looks like very weird. See. Yeah. Let me close it and open it again. Okay. So I have Arena now up. And let me share the screen with you. This one. Okay. So now we are in Arena, and we will try to model this this example using Arena. So we're going to start by defining the schedules. Okay. So as I mentioned, the Arena software is no longer offering that option in which you have that pretty nice interface to set up the number of arrivals per time period. So we're gonna have to rely into the new template. But before we go to that, let me save this. So sample. So we're gonna start with that. Let's go to basic process, and let's find schedule. Click on that, and then we're gonna double click. We're gonna name the schedule. We're gonna provide a name. So in this case, I'm gonna name mine arrival schedule. Okay. So this arrival schedule is for arrivals. We're gonna use time units hours. Scale factor is gonna stay the same. And here's where we're gonna specify the different arrivals per hour. So we're gonna click here into durations, and we're gonna double click, and we're gonna add a row every time there's a change in the number of arrivals, in this case per hour. So if you see in the example, from 12 a.m. to 10 a.m., we have four arrivals per hour. So that's gonna change my value to 4. and I'm gonna tell the model that this is going to be for 10 hours or 10 time periods in this case. Okay, so from 12 a.m. to 10 a.m. Those are 10 hours. Then I'm gonna move to the next change in terms of the number of arrivals. So in this case, it's 10 arrivals per hour. And this is gonna go from 10 a.m. to 6 p.m. Okay, so those are 8 hours. And then finally, I'm going to use the 8 hours. And this is gonna be for 6 hours, or for 8 arrivals for 6 hours, or 6 time periods. Okay, so we need to understand something at this point. We want to make sure that if we are telling the model that our time zero is going to be 12 a.m., we need to be consistent with that time. Okay, so from now on, since we started with 12 a.m. as our time zero for the model, everything that we do from now on has to consider that our time zero. Okay, so if I'm going to be computing something like the statistics that is asking us to compute the mean number of customers at 6 p.m., then I need to make sure that when I compute that statistic, I'm thinking that my time, or that I'm using time zero as 12 a.m. And we'll see how that works in later on. So we have our arrival schedule. Okay, and now we can start creating our model. So we have a create block. And in here, we're going to specify the arrival. You see in the type, we can select the schedule type, and that's going to bring the option of selecting the name. So in our case, it's arrival schedule. Click OK. From there, we need to set up some attributes for our entities. We are interested in the working process and also the cycle time. So we are going to define an attribute for the arrival time. And that's going to be tnow. And we're going to add a variable for the working process, so WIP and WIP plus 1. From there, we need to add another attribute to our entities, and that attribute is for the time it's going to take for them to pay. So I'm going to be using a decide block here, and I'm going to be splitting this by 50%, and then I'm going to use another assign block here and another one here that are going to be splitted, and this is going to be pay time. So this is going to be an attribute. It's going to be called pay time. So 50% is going to be 2 minutes. And then I'll go to the next assign block. For this guy, I'm going to be using the same attribute. It's called pay time. So I'm going to find that one at the end, at the bottom. And for this guy, that's going to be 5 minutes. Okay. So from there, I had to specify the time customers are going to spend in the system. So for that, I need to use a delay block. And I can use a process block here just to, let me see, use it as a delay. And this is going to be a gamma distribution in minutes that is going to be using 5 as the beta value, 5, and alpha is going to be 4. Okay, so from there, what is? We can go to the cache here, which is going to be a resource. So we need the sysdelay release. And I'm going to call these the cache here. And the time it's going to take is going to be based on expression in minutes. And the expression is pay time. Okay. So there's something. Okay, let's complete the model in terms of the statistics. Okay, so I need to do an assign block here to go to decrease the working process. So WIP, so it's a variable WIP, and this is WIP minus 1. And from there, I need to compute the cycle time. So I'm going to use a record block. And this is for time interval. I'm going to use arrival time, and the name of the tally is cycle time. Okay, so from there I can dispose, and I still have to compute or collect the mean number of customers at 6 p.m. So let's do that. For that, I'm gonna use a separate logic. That is going to generate an entity when needed to collect that value in a tally. Okay, so I'm going to use a record block, and then I'm going to dispose that. Okay, so this is how this is going to work. Remember that I mentioned that we needed to consider our time zero, as we specified the schedule that our time zero was 12 a.m. Then the model is going to assume that 12 a.m. is time zero. So if I want to collect something at 6 p.m., then I have to start counting the number of hours from 12 a.m. until 6 p.m. Okay, and I'm going to generate that entity every 24 hours, but I want my first entity to be generated at 6 p.m., which is time 18. Okay, so the first entity is going to be generated at 6 p.m., and then from there on, every 24 hours. So every day at 6 p.m., I'm going to be collecting a number for the working process. Okay, so I'm going to go here to the record, and I'm going to use an expression. The value is the working process, and the tally name is WIP 6 p.m. Okay, so let me save and check my model. Okay. So at this point, there's a couple of things that are still missing. We need to, let's set up the statistics. Statistics. So we have the Cycle time. So let's generate an output for the cycle time. So this is TAVG cycle time. And the name is going to be average cycle. And then we have to define a time persistent statistic for the working process. So this is WIP. And the label